caller on, and it looks like we have a very special one here. Let's see here. Wages World. Oh, we've got Wages World.
Hello?
Wages World, what is going on?
How you doing, Adam? How you doing, man?
Good. So obviously there's some big news in your area, what you study. So can you explain what's going on?
Yeah, sure thing. Yeah, we've got some incoming solar weather. We had a C-class flare that had a C.M.E. that was accompanying it just behind it, probably about an hour or two after the flare blew. But it's a big one. It caused a full halo C.M.E. that was directed right at us. So it's significant. It's probably the biggest one we've seen in a few years. That's going to hit us.
Because you follow this, you follow this all the time. Is this something that how insignificance? Is it really truly the biggest one we've seen in years, or is it just the biggest that we've seen that's actually hit us or pointed at us?
The latter, what you said there. But the thing I would say there is that we really don't know sometimes when it's not pointed at us how strong they are, especially the ones that are on the backside, because we don't have no detectors back there. We don't have any data collection. So we just got to go off of visual and what we can see from like stereo A. That's kind of giving us a side view. Now we are getting some more data collection with like the Parker SP probe and a couple other satellites they've sent out there, but those are just now getting kind of operational and starting to build some sort of a historic data collection.
Now, Now, did you say that this was a Class C? There's three categories. There's X class, there's M class, and then there's C class. Can you explain those three, or do you know?
Yeah, I can remember. That's actually fairly easy to do, fairly quick. Actually, there's 5 classes. It starts with A, B, and C, A, B, C, M, X, and X. That's what they go off of. And essentially, I guess the first thing I would say is we can't confuse a flare with a CME, because a lot of people do that. It's not the same thing. Now, a lot of times you get 2 of them, like when you get a bigger flare like we had, it causes a CME behind it, and that's exactly what we're seeing here. So the initial flare, even though it's a C class, it was a higher C class, but it wasn't, the CME behind it is actually more of a problem. That's kind of what we're looking at right now. But as far as the classes go, it's based off of X-ray level. And that's how they map these things out. In a C class, we see those are actually fairly common, and we don't, it's fairly common to those of us that have been looking at this for like 10 years. People that are just now getting into this probably haven't seen too many C class flares because we were in a solar minimum. When that's happening, there are no sunspots at all on the sun, pretty much. We set a space age record in 2019. We were at 77% of the days throughout the year that had no sunspots facing us. That was a record. So, but the following year, which is this year, we have had a tremendous increase in the percentage even. If you go back and compare the last the same 2 years in the previous solar cycle, you're going to see that it was only a 2% increase from the deepest part of the minimum to the next year. It was 73% to 71%. Right now, as we sit, if the year was to end today, there is a 17% increase. And that is significant because our magnetic shields, our magnetic field is 20 to 25% weaker than what it was. So it doesn't take as much of a flare or a CME to really give us some issues. Now, if this one is getting ready to hit us, there was a solar wind stream, and this is what's made this one kind of difficult. there was a solar wind stream that was headed our way anyway. This is days before the CME ever even happened. The charts and the graphs were showing it to be upwards of 50 on the density part of it, which a normal density would be 4, normal conditions. So a 50 is very, very elevated. We haven't seen that number actually on the inlet models, I know, for 2 years. So that's very significant. And that was just the solar wind stream from a coronal hole. Then we had the C.M.E. right behind it, and that happened. So what we're looking at right now, we were actually, the predictions came out, a couple of days ago when this happened, and we should have already been into storm level and been seeing this stuff like 12 hours ago. But it's moving slower than what they thought.
Now,
the prediction models were wrong.
Could we see this affect any kind of services or internet or power or anything like that?
Yes, I would have to say on something like this, what we're getting ready to experience, because actually right before I called, I checked the where we were at, and we had moved from a 2 on the KP to a 4 within the last 3 hours, and a 4 would be very active, and that's one number under storm level. So the next one that comes out, unless there's a good chance we could already be in storm level. But to answer your communication question there, yes, that would probably be, for me, that's probably the biggest thing that would happen with something like this right now. At this point, yes, we could see.
Can you just make sure everybody knows what you mean by storm, like a solar storm? Is that? Can you just
okay? I can explain that real quick. Yeah. It's a geomagnetic storm. And I'm glad you asked that, because that is important to know. Like I said, at the beginning of the call, the solar flare in a geomagnetic storm is different. The geomagnetic storm comes with the C.M.E. That's charged particles that travel from the sun to us, and that's all done through magnetics, our magnetic connection line between the sun and the earth. Those particles stay on that line, and that's how they get here. And that's true with the solar wind also. But a flare is X-ray. So the initial blast from a flare, we get no warning for. It's here and gone in 8 minutes. That's just as simple. It's like taking an X-ray, like you go to the hospital. But the storm level stuff is caused from those charged particles. And when it hits our magnetics, it hits our shields. Depending on how fast it is, how dense it is, that's what will push us up into stronger stuff. Obviously, the faster and the more dense it is, the more that's going to affect us. This one, this was significant. And once we get those charged particles hanging around, if you get a C.M.E. behind it, all it does is intensify everything. So that's kind of what we're looking at with that. And people want to know what a charged particle is. It's plasma. It's, that's what plasma is. It's charged gas. That's the only difference. The only difference between gas and plasma is it's charged. That's why it follows like electrical properties and magnetic properties. So that's why we can manipulate it like we do, but it's also what the sun sends at us, and that's why it affects us so drastically when we get hit with these big ones. And this is a big C.M.E. Like I said, the C.M.E. part is really the problem. It's not the flare part of it. The flare actually, when it blew off, sometimes we get a radiation storm with that, and that didn't really happen. Radiation storms, astronauts get kind of freaked out over that, obviously, because they're out in space with no, magnetic field to protect them. So that can make them sick. It can do all kinds of crazy stuff. But, for us here on the surface, it would take an extremely big flare to really give us some problems, like health-wise for us. Now, you were talking about like the Carrington event earlier. I would like, I really want people to know that is not the only event. we had one in 2012 that would have stuck us in the Stone Ages. That happened. It missed Earth by 9 days. And that doesn't get talked about a lot. And it should. That should really wake people up when they hear that, because it hit the detectors. It came in at an X28, and that's what the Carrington event came in at. But it overwhelmed the detectors, and after they analyzed it even more, it came in at an X45. So that's how close we came. You know, if that had fired 9 days later, we wouldn't be talking right now. It's really that simple.
And again, X is the worst. Yeah, being that, you know, X class is, these are big, massive, just boom, and that would have put us in the medieval ages.
Yes. If you pulled up Space Weather Prediction Center, I'm sure you've probably been there a lot. I would imagine you've probably been there a few times. The NOAA site. Yep. If you look at the top there, it tells you, you'll see the flare classes right there at the top on the left hand side. And what it does is, what you will be looking at there again is it'll show you A, B, C, M, and X. They keep them like a C1 through 10, an X1 through 10. The only time they go over that is when they absolutely have to. And that's where it falls at. They don't really have a name past an X. So the number just gets bigger and bigger and bigger. But it's very significant what we're dealing with now because of everything that was around it and the fact that our magnetic field is weaker. There's really not a whole, when all that's coming in at once, that can really give us some issues. And if you look at the prediction center there, just to the right of that, how can I put this? The right of the graphs, they actually tell you, they give you a time frame. Yeah, you're scrolling there right there. You see the G3 right there at the top?
Yeah, so it's...
I'm not sure if you can see that orange box or not.
Yeah, it says...
that orange box, that's their prediction. They're saying that, not me. Okay, so, but if you scroll down a little bit, you'll see on that data, it's this text. It's texting data right there. Underneath, there's actually a time frame. It'll tell you what kind of range they think we're going to be in by time. But I would say, like I said before, it is, you're on the wrong one, but it's okay. It's no big deal. They map it out by time. Now, if we'd have looked at this yesterday, this was 24 hours different. They literally moved everything back a day. And that's why I've cautioned so many people from setting dates on this, because they're so unpredictable. We don't know until the stuff hits our detectors. And that doesn't happen until, days later. Not the main ones. So, that's why it's so important for us to really stay vigilant with this and look at it and keep an eye on it. Because there were a few channels, because you try to figure out what part of the Earth is going to be facing the sun when the brunt of it hits, because that will take the hardest hit. Now, it will still blanket around the Earth, and the whole Earth's going to be affected by it. But the big initial blast, like what happened back in 1859, where the telegraph operators were getting shocked, stuff was catching on fire, all that kind of stuff. That happened on the day side.
Well, and
most of that.
And real quick, I just want to pause. Jonathan Nunn, I did see your message. I'm going to read that here in a second. But you do have a question from Liz Gaspari. Says, okay, geomagnetic storm. Wow. So what should we expect? That was a question.
Okay.
Looks like it's directed towards you.
That's a good question. It really is. There is actually, if you were to go back on my last live stream there, I've been showing it for the last 3 days I've shown it. You can Google search it and you'll get different things, but what I showed was the conditions you can expect for each level of storm. And it really doesn't start getting bad or any kind of thing really, really significant till you get to a G3. So that's when it really starts to become an issue sometimes. Now, the cool thing that we see is aurora. That's a very, very big indicator of how strong a solar storm is of any sort. The further they come down closer to the equator, the stronger it has been. For an example, you would see that on the Carrington event, they seen aurora at the equator. It was in the Caribbean. That's how big that was. That's very, very significant. You know, a typical aurora, yeah, you're looking at that right there. Yeah, that's a good graph to look at. And what you're looking at, that, you know, when you click on that, what you see at the end of that time lapse, that's the actual current real-time last capture. So you can see where if you roll that around, you'll see the termination line of day to night. And obviously it's on the night side where we see them. But you can actually pinpoint where the most of the energy is coming in at by finding the thickest part of that and just drawing a straight line.
Whoa.
Because it's usually about directly facing the sun.
Whoa, look at that. It's getting big.
And there's a reason it comes in on the poles, because it's just where it comes in at easier. So yeah, it is definitely something that the aurora photographers are going to have a great couple days. I would look for some really, really cool auroras happening. I would look for them to get down into Oregon. It could get into Colorado if it's strong enough. We've seen that before.
Let me ask you this: in Washington,
when they get down,
will I have a chance to be able to see this myself?
Absolutely.
Wow, incredible.
Yeah. Oregon's further south than you, brother.
Well, I know, but you never know.
So yeah,
I don't know how these things work like you do. So,
well, what happens is, yeah, when they come in, that's what they do. The further,
maybe darker
there. Yeah, you would have to be somewhere where it's out. You wouldn't want city lights around by no means. That's, you know, obviously where you live and stuff like that would have to come into play there a little bit. But what happens is it comes in through the poles the easiest. So when it does come down through there, it's traveling through our atmosphere. So it just kind of, it can only make it down so far before it doesn't react with the oxygen atoms enough to actually cause that green reaction. So that's what you see when you see aurora. It's the actual charged particles smacking into the oxygen molecules, and it's that reaction. It's the reaction going back to a stable, more neutral atom, not atom, but yeah, an atom, but oxygen atom. It's that oxygen atom trying to get back to normal. Well, that's what you see.
Well, wages.
And if it gets down, if you see like pink or red, that means it's actually getting down further in our atmosphere. Because that means it's getting down into the nitrogen atoms. And those are closer to the surface. So that's another indication where we can see.
Now, yep. Wages, we're gonna attach your information, your channel, and then do you have a website now? I didn't know if you ended up getting one yet, or
no, I don't have a website. No, I just I come on there, and here lately I've been kind of, I struggle with some of the stuff that I put out because it's pretty negative, Adam. You know what I'm saying? I try to find a good positive outlet, and actually, I found Mark Pyre's Real Talk show, and I've been going over there just cracking up, dude. It's funny. I would love for everybody to go check him out.
So I heard you were doing some you were doing some sketch comedy last night, I think. Is that right?